I'm Dave Masten, Masten Space Systems. We are a small corporation developing a reusable vertical takeoff, vertical landing vehicle, and in conjunction with creating those vehicles, we've gotten into the business of making reusable, restartable, reliable rocket engines. The engines we've developed so far are all 500-pound thrust range, several different design variations on a basic rocket engine. This is one of the rocket engines right here. It's a 500-pound thrust, runs on isopropyl alcohol and liquid oxygen. The engine is regeneratively cooled, so it can run basically forever, indefinitely. The design parameters that we went around were that it needs to fire 1,000 times or more to be acceptable to us. This is quite different from a lot of rocket engines, and most rocket engines are built, designed to be flown once and then thrown away, or in the case of the space shuttle, flown once and then completely rebuilt and used again. Ours, just reuse it again. No need for inspection except for every 100 or so firings, and maintenance is very low. And part of how we are doing this is a little bit heavier than a rocket engine normally would be for the amount of thrust, but that's just to give enough metal material around it so that it doesn't have any problems with fatiguing and wearing away after use. And we've recently been talking with the Orbital Commerce Project about how to build and use one of these rocket engines in a airframe and more of an airplane type situation. This is one of our normal flight weight engines. As you'll notice, there's a lot of copper and there's an aluminum saddle that fits around this. Makes it a lot lighter. This, on the other hand, is more like what we'll be using for an airplane. And you'll notice there's no aluminum saddle here. It still works just the same. It's got all the throat and everything else, and it's still regeneratively cooled. But it's about twice as heavy, just because we didn't cut out any of the excess copper. And so this particular engine's been fired somewhere around 200 times. Longest duration firing on this particular chamber was 42 seconds. We have another chamber that's very similar to this that we have fired for 94 seconds at the X Prize Cup and 90-some seconds several times here at our own test facility. One of the problems in interfacing a rocket engine to an existing airplane structure in place of the piston engine and propeller is that rocket engines, for the amount of thrust they get, are much lighter in terms of weight. So we're basically, if I understand right, replacing a 250-pound piston engine with, well, our engines come out at 50 pounds. So we've got a bit of a weight difference there, and that creates some problems with the airplane's weight and balance. So fortunately, we can make the engines just a little bit beefier, a little bit heavier, and hopefully a little bit more reliable. And also build it a bit quicker and a bit faster.